Hello, welcome to my Tech Fun. A few months ago I created a video where I was testing optimal position for 3D printing bolts and screw nuts, and there I'd get a lot of comments to I should test different materials like PETG is much better, only ABS or nylon can be used for these purposes. That will be tested too, but now in this video I am testing FDM 3D printed bolts and screw nuts versus SLA 3D printed bolts and nuts. This is the most common material, which is the PLA, and of course versus resin. I got a lot of questions why to 3D print bolts. Well, first, my first imagination was to do this test to see what is the optimal printing position for threads themselves, which may be part of your object. But then I got very interesting comments that somebody are actually using these non-metallic bolts. They are used in electricity, and also a very interesting comment I got that somebody really used these plastic bolts with the toilet because it will not scratch the ceramic. Since I don't have SLA 3D printer, I use a printing service. These are M6 by 20 millimeter bolts and also M6 nuts. For 6 pieces I paid $19. I get 2 extra pieces from each, and so you must understand why I don't have so many test probes, only 2 per test. Since I don't have any experience with SLA 3D printed parts, I would like to analyze these resin bolts and screw nuts. And of course, first thing is to check if I can screw on the nut to the bolt, and I notice it's on, but at the end it stops. And then I analyze it a little bit better, and I find out that the reason is so-called elephant foot, where the object is attached to the bed. It's a little bit bigger. Just to be sure, if really that's the problem, the metallic nut should go on resin bolt, and yes, it's on it. And resin nut shouldn't go completely on a metallic bolt. And of course I also tried the PLA nuts, and it's also very tight, but they goes on bolts. So inside on inner thread I can solve this problem with the M6 step tool, and I can clear the thread holding it in my hand, so I don't even need the vise. But outside it is still a problem because it doesn't go into the wrench, and the same problem I have with the bolts. I checked the dimensions of this flat surface, and it's approximately 10.1 millimeters, but on the edge it's approximately 10.45, so it's too big to go inside the wrench. On metallic bolts this dimension is approximately 9.8, 9.9 millimeters, and on PLA bolt it's 10.1 millimeter, but they go into wrench without a problem. So this problem can be solved with the sandpaper or fire tool on those edges. Sandpaper is a little bit better because you don't have to clear the file at the end of the work. And resin bolts are now almost ready to use. And just in case, I'm cleaning them with the die tool. And then I noticed that outer diameter of the bolt is reduced from 5.9 to 5.8 millimeters, so they're reduced by 0.1 millimeter. In theory they should be 6 millimeters, but this dimension is always in minus of tolerance. And for example on metallic bolts this dimension is 5.75 millimeters. Okay, next is to analyze the PLA bolts and screw nuts. Bolts are printed in horizontal position because they are much stronger, but there is a problem with the surface quality. So those support marks are still there and they are very visible. And not even metallic nuts can go on these bolts now. But key to this problem is the M6 die tool. So cleaning is very easy. I can do it again holding in my hand without using a vise. And after cleaning the thread, all 3 types of the nuts can be screwed to the bolt, and they go on it very easily. PLA screw nuts are printed in horizontal position. This means the thread is in vertical position, and they're almost ready to use straight from the 3D printer, but just in case I clean the thread with the M6 step tool to have the same dimensions on all used screw nuts. And now it's time for testing. So let's break some plastic. This is my testing setup, 1-ton chain hose, but weaker point is this crane scale, which is 500 kilograms, and I can attach here the other side, so I can measure up to 500 kilograms. That's the limit of this setup. This will be the main part of this testing setup. Broke here, but I'm not sure. I have to take this out somehow. So it's not tight, I can turn it from the other side. SLA bolt. Broke where the head was. Broke here where the head is. As planned, it broke on 3 pieces. Resin bolts, Shear stress number 1. Broke on 4 pieces. A similar break, 4 pieces. It explodes actually. This is my new setup for torque test. This will be only a washer and a 40 kilogram hanging scale, an open end wrench. PLA bolt torque test 1. So PLA bolt is in combination with metallic nut. I'm rotating it until I reach the ultimate strength, the maximum torque, and then something breaks and then it starts to reducing. So this maximal value I'm recording for comparison. Grid shared. Resin, bolt. Oh, it broke. Yeah. Too brittle. Broke too suddenly. Same story. Both broke. Huge difference on this test. So here the thread was shared, but it was still on it, and here with the resin bolts they broke very suddenly. So theoretically the PLA is very brittle material, but even it perform much better than the resin bolts here. So next test with the PLA screw nut, and this hole is same size as a washer for M6, so I don't need a washer here. Pull out the threads. And again, thread pulled out. And now it's time to test the resin nuts. Interesting, it broke in a cross section. This time the thread is sheared out. Well, now I'm a little confused because I already did test with the PLA M6 screw nuts, and they broke under maybe 70 kilograms or something like that. Then I analyzed what is the difference, and the biggest difference is this hole here. On new setup it is 6.5 millimeters, and on my previous setup it is 7.2 millimeters approximately. It looks like this has so big effect because everything else should be the same. But anyway, this is only comparison test, so setup is same for these two materials. And here the plastic nut is used in combination with metallic bolt, and again I'm rotating until it reaches the ultimate strength, so the maximum torque value. Something breaks, and when it starts reducing I'm recording that maximum values for comparison. I think the thread is shared now. Doesn't look bad. It's damaged a little bit, the thread, but it looks good. Okay, I think now the thread is damaged. Oh. Not bad actually, not bad. And now resin nut test number 1. Oops, it broke. Wow. And the same way. So they broke on the same way. And very interesting, the PLA nuts are almost usable even now after some tree damaging. In this page I summarize all results, since I have 2 tests per each type. With the red I'm calculating the average values. And for comparison, in this table you can see PLA and resin in percentage. And here on this graph you can see visually what is the difference for each test between PLA and resin. These are average values. The conclusions, well, you saw the number, but beside those values there are other things. I'm not sure can it be seen on camera, and that's the feeling. This resin was very brittle. It breaks too suddenly compared to the PLA, actually I feel that when it will break. I thought PLA is more brittle compared to the PETG, but I'm sure there are other types of the resin. Maybe you can give me some suggestions in comments. But this tested object was very brittle. It breaks very suddenly without any warnings. This resin object was printed in vertical position. Everybody on internet is telling that here the orientation doesn't matter, but the company I ordered these bolts, they told me maybe they have a feeling that there is some differences, so that will be tested in my next video. But now let's pronounce today's winner. So, winner of this competition today is PLA. Sorry about that. Actually, I wasn't sure about the result before I started this experiment, and also I'm very curious what will be the result between injection molded and PLA bolt. That will be tested too in near future. Thank you for watching and happy printing. Bye.